Hi all, welcome back. Before this class, we have taken a look on our practical scenario, means practical hands-on lab, that how to create the VPC. Now, in this theoretical part, we will be seeing that how to create VPC subnet. Subnet stands for sub networking, means we will be dividing our VPC into further components. Now, this is our topic. So, let us go to our introductory part of the topic. It says that a subnet is a segment. What it is? A segment is a segment of partition of the VPC's IP address range where you can isolate groups of resources. Now, to understand this definition, I have taken a simple diagram. This is my VPC, which I have created. Got it? Now, I previously said that a VPC we will be having a CIDR block range and it will be having an IP prefix. Now, the IP prefix is 10.1.0.0. The CIDR bits is 16 bits. And inside that VPC, we have got two IPs. Now, what are the two IPs? The two IPs are public and private IP. Now, let's take a look onto what is public means. What are the components that comes under the public IP? Inside this public IP block diagram, we have two EC2 instances. Two EC2 instances. And this is the private IP diagram. We have only one EC2 instances. Now, VPC, this is the VPC. We have got two IPs on that VPC, public and private. And inside our public IP, we are running two machines, means the EC2 instances. So this is how the whole subnetting will look like under VPC. We are having a VPC cloud. Inside that, we are isolating, where is the thing written? Isolating groups of resources. We are isolating the EC2 instances on the basis of what? The IPs. IP means public and private. Now, let us move on to our next slide. It says that subnet of the VPC CIDR block cannot overlap. Yes, of course, it cannot overlap. Because if it will be overlap, then we will be having the resource group conflict. Here is written ISO, means the main function is that to isolate. So we don't want them to overlap. Now, just one quick note I am want to give you. AWS reserves 5 IP address from each subnet. Means this is a VPC, and inside that VPC, the AWS will be reserving 5 IP addresses from each subnet. And also on second note that this one, an availability zone can contain multiple subnets. Now, just a quick short note that subnet is not a region-based service. Subnet is an availability zone service. Now, what is the service comes under the region base? The service that comes under region base is our VPC, not the subnets. Let us move on to our next slide. Next slide is all about the route tables or the routing tables. Now, routing table will be having two parameters called as destination and route. Let us read out the definition and try to understand this. A routing table moves the traffic inside a VPC Got it? It moves only the traffic which is coming like inside the VPC, that is coming from a gateway. That is coming from a gateway. Gateway can be internet gateway, or gateway can be anything. Now that is coming from the gateway and it divides among subnets. Now what are the advantages of using the routing table? Required to direct traffic between the resources in this first diagram. The EC2 instances are divided via the public IP. Got it? So this is saying that required to direct traffic between the resources. On that diagram, we are having the EC2 instances as the resources. Each VPC has the main default route table, means it means whenever we will be creating a VPC, the AWS will be automatically giving us the default route table. But that doesn't mean that we cannot create our custom route tables. Yes, of course we can create that. The last point is very much important. All subnet must have an associated route table, because if we will not define the route table with the corresponding to its subnet, then where are the requests or where are the traffic will go? Got it? Now let me just give you another note that I've said that AWS reserves 5 IP addresses. These 5 IP addresses are as follows. First is your network ID. Second is your broadcast ID. Third is the internet gateway. Fourth is the routing table. And fifth is the NAT. NAT stands for network address translation. Now let us see what is the meaning of like the network isolation. Means we can further isolate the networks on the subnets. Same as the VPC, it will be having two major parts, public and private. So a subnet can be a public subnet, a subnet can be a private subnet. Got it. Now, there is one definition written here. Just take a look at this closely. It includes a routing table entry to an internet gateway to support inbound and outbound access to public network. Now, let me give you an example. Suppose we want to download or we want to do like download a song or download a movie. Where we will be? We will be going to google.com. Then we will be writing our that download this. Then it will redirect to a website. Now, when we will be sending, means when our request will go to Google, then only it will send the Google page. Got it? Now, the sending of the Google page and the interacting of the web is called as internet gateway, the gateway to the internet. And it also supports the inbound and outbound. Means from our public subnet, we can interact to our internet via internet gateway, means that is outbound, and inbound means that the reverse thing is happening. When we download our file, the file will inbound, means come towards us. That means it supports the inbound access to public internet. The second thing, the private one. Now in the private one, we are having the fifth point that AWS reserves. It has the NAT gateway, network address translation. Every public subnet and every private subnet will have its own IP. That is called as public IP and private IP. Same. Just take a look at this one. Do not have a routing table entry to an internet gateway. Now this is where the catch comes in. When we were at the public subnet, we can easily go to our web browser and all, and we can do the things like a download song or update our Windows, anything. But what is the situation comes under the private subnet? The thing is that We cannot access the internet gateway. I'm using the term here, internet gateway directly. We can only access it via some special gateway that is called as NAT, means network address translation. Typically use a NAT gateway to support restricted outbound public internet access. Yes, it restricts the access for the public internet access. Now, here is the scenario. What is the scenario? We are having the routing table. This is the route table. We got our diagram, whatever this all example will be of. We got some points here. Now let us see. In this, first of all, it is a VPC. Inside that VPC, we are having two subnets, public and private. Fine. Inside our public subnet, we created one what? VPC NAT gateway. VPC NAT gateway means network address translation gateway, onto which our public subnet. In our private, we have created an instance. We can call it like instance with private IP. Fine, cool. After that, consider the scenario of private subnet. Now, here I am at the EC2 instance. I want to access the internet gateway. Now, how I will be accessing that? Our instance, our machine will be sending the request to not directly to go to internet gateway and ask him like, hey, give me this song link or give me this website. It will not ask. It will be asking via some other route. Now, the request will be assigned to NAT, means network address translation. It will translate the address. It will translate the private address and it will be sending the request to internet gateway. Then only we can see the website or whatever the request was there. Search request, website request, anything. Now, in this routing table, we are got two parameters, destination and port. 0.0.0/0 is the internet gateway ID. We are considering some examples here. And let's take a look at these 3 points. It is said that allow communication between instances in your VPC and the internet. Yeah, fine. The internet gateway is allow the communication between the internet and the means that private cloud. VPC are horizontally scaled and redundant and highly available by default. Means by default it is highly scalable. Now let me give you another example here. At the old days, what we were doing, we got one landline, and within that landline we got something called as extensions. Now that extension thing is private IP. Outside people cannot contact me. Okay, outside people means the internet people cannot contact me, or they cannot see or know my that extension code. But what is the opposite scenario? I can contact to the world. I can contact to the world via this NAT. So that means that there has to be some kind of translation. Means, suppose I got a landline with a extension code. Now, on to that extension code, first I will type a number, suppose 9. And after that, I will be typing the public numbers. Means 100 or something like that, 9483 something. Now that means that 9 is my NAT there, network address translation. That means if I am having a private IP, I can always contact to our world, but outside world cannot see our this private IP. What is the scenario of hacker here? Hacker will be only seeing this IP, NAT IP, VPC NAT IP. The hacker will never know the our machine private IP. So it also comes under that it provides us the security layer also. Now this is the connecting private subnets to the internet. Now, in this previous slide, we have talked about the internet gateway. Now we will be talking about the NAT gateway. Consider the same example. We got the public, private route table. This is our same machine. This is our NAT, and this is our IG, internet gateway. Now, if I want to update Windows, suppose my EC2 instance is running a Windows, then the request will first go to NAT, address translation, and after that request translation, it will send the request to internet gateway. From that, I can access the update website. Yeah, and after that means our that let us consider again that hacker scenario. The hacker will only know the NAT part. The hacker will not be knowing our machine part, means that instance IP, that private IP. Now, here we got two tables, and after these two tables, we can define that from where is the destination and where is the port, means that this IGW refers to the internet gateway ID. And obviously, in the private table, we will be having our what NAT, because NAT is not required in the public side. Public subnet can directly access to our internet. The NAT ID is only required onto our private route table. Okay. And after this, we are left with our another topic called as multi-VPC scenario. We will be taking a short break, and let's move on to that. Thank you.